Hello and welcome. In this lecture, we will set up the Virtual Private Cloud, commonly referred to as VPC. In the previous lecture, we have discussed the overall AWS architecture where to run the DevOps Buddy application. There is a lot to it, so it's better to go through little steps each time. Learning AWS, like anything else, is a matter of practice. The more you practice, the better you become. There are also training courses that teach you AWS more in detail. I've written a blog on my journey to get an AWS Solution Architect certification. There, I explain all the resources that I used and the courses that I followed. If you want to know more, visit http://devopsfolks.com/blog. From our architectural diagram, we know that we will have to create a VPC with public and private subnets, and that we will deploy our application to two different availability zones. I'll choose EU West 1A and EU West 1C, which are both located in Ireland, because that's the region closest to me. You should choose the AWS region closest to you, which offers at least two availability zones. Now, we can head up to the AWS console by pointing our browser to http://console.aws.amazon.com and logging in with our account credentials. Once logged in, we can click on the VPC link under the networking section. Here, you should see that there's one active VPC. As briefly mentioned in a previous lecture, each new account is assigned a default VPC. The first thing we will do is to create an elastic IP address. This is a public IP address that we will attach to the NAT gateway. If you don't remember what a NAT gateway is, please refer to the architectural diagram that we have discussed in the previous lecture. To create an elastic IP, we can click on the Elastic IPs link on the left and then on the Allocate New Address blue button. When asked whether you are sure, click Yes, Allocate. There is a small charge if we don't associate an elastic IP address to a resource, but since we are going to associate it to our NAT gateway, you should not incur any charges at this point. Also, please note that there is a small charge for a NAT gateway per hour. In Ireland, for instance, which is the region that I'm using, there is a charge of 0.048 cents per hour. Now, you can click on the VPC dashboard link on the top left menu and select the Start VPC wizard button. As per our architectural diagram, we will choose the VPC with public and private subnets and press the Select button. We can leave the IP CIDR block to 10.0.0.0/16. If you don't remember what the CIDR notation is, I suggest looking it up on the internet. Basically, you take the number 32, subtract from it the number after the /, elevate 2 to the power of the result, and that gives you the number of IP addresses available. AWS reserves 5 addresses for internal use. So, if we take 32 and subtract 16 from it, the result is 16. If we elevate 2 to the power of 16, we obtain 65,536. If we then subtract 5 addresses from it, we obtain 65,531 IP addresses available within the VPC. As VPC name, we will specify DevOps Buddy. For the public subnet, we will set the CIDR address to be 10.0.1.0/24, which gives 251 available IP addresses. I will choose EU West 1A as availability zone, and I will name this public subnet as public subnet - and then the name of the availability zone, in my case EU West 1A. This is a good way to immediately identify to which availability zone a subnet belongs. Again, following our diagram, we will set the CIDR address for the private subnet to be 10.0.2.0/24. I will call this private subnet Spring Boot subnet - EU West 1A, and again I will select EU West 1A as availability zone. Now, we need to enter the elastic IP for the NAT gateway. If you just click on the text field, it should automatically suggest you the elastic IP that we have created a few moments ago. Next, we want to add the ability for our VPC to connect to S3 from both the public and private subnets. So we can select public and private subnets and full access as policy. Please leave everything else as is. Especially, don't choose dedicated tenancy as hardware tenancy, as that's very expensive. Once done, click on the Create VPC button. I'm now going to pause the video until this process completes, as it might take a few minutes. We are not done yet. The wizard only creates one public and one private subnet, but from our architectural diagram, we know that we need 2 public subnets and 3 private subnets. Luckily, creating a subnet is really easy. We can click on the subnet link on the left. Please note that the links are roughly in the order in which we should perform operations to create a VPC. You can filter the DevOps Buddy subnets by selecting the DevOps Buddy VPC from the drop-down in the top left menu. So far, you should be seeing the public and private subnets that the wizard has created for us. We can click on the Create Subnet button to create the second public subnet. We will call it public subnet-EU West 1C, or another availability zone if you have chosen another region. Make sure to select the DevOps Buddy VPC and not to leave the default. I will choose EU West 1C as availability zone and, according to our architectural diagram, set the CIDR IP address to 10.0.3.0/24. Next, we will create the second Spring Boot private subnet. I'll name it Spring Boot subnet-EU West 1C. Select the DevOps Buddy subnet, EU West 1C as availability zone, and following our architectural diagram, we set the CIDR address to 10.0.4.0/24. The last subnet we need to create is the MySQL RDS one. I'll call it RDS subnet-EU West 1A. Select the DevOps Buddy VPC, EU West 1A as availability zone, and set the CIDR address to 10.0.5.0/24. Now, if you click on the public subnet created by the wizard, which in my case is public subnet-EU West 1A, you will see some information appearing in the bottom half of the screen. If you click on the Root Table tab, you will see a few entries. This means any traffic coming from the VPC is considered local. Any traffic addressed to the S3 entry point in Ireland should be forwarded to the S3 entry point that we have asked the wizard to create. Finally, any other traffic should be routed to the Internet Gateway. This is how a subnet is defined as public. The wizard has created an Internet Gateway for us and has attached it to the VPC. If a subnet is attached to an Internet Gateway, it's reachable from the Internet and therefore is considered public. We will now need to associate the public subnets to the public root tables and the private subnets to the private root tables. If you click on the root tables link on the left and then on the one showing one associated subnet, again you will notice the details appearing in the bottom half of the screen. Here you can click the Subnet Association tab and click the Edit button. Now select the other public subnet and click Save. If you now go back to your subnets and click on the Spring Boot EU West 1A subnet, you will see that the route table is different. The first 2 entries are the same as the public route table. However, any outbound traffic goes to the NAT address. If you click on the route table link, you will be directed to the route table page. In a VPC, all subnets need to be associated to a route table. In our case, we want to associate the private subnets to this route table. This is easy to do. If we click on the Subnet Associations tab and on the Edit button, we can associate all private subnets to this route table. These are the 2 Spring Boot subnets and the RDS subnet. Finally, we want to set up security groups. Security groups act as a firewall at the server level. By default, they allow all outbound traffic and no inbound traffic. Therefore, we need to open the necessary inbound ports for our application to work. First, we will create a public security group by clicking on the Create Security Group blue button. We will name it Public SG and make sure that the name tag, the group name and the description all contain the same value. Then, we will select the DevOps Buddy VPC and click Yes, Create. Now, we will create a Spring Boot security group following the same process. Then, we will create an RDS security group again following the same process. Now, we will create a Bastion host security group. You should now have a total of 5 security groups: a default one, a public one, a Spring Boot one, an RDS one, and a Bastion host one. Now, we can set them up. We will start from the RDS one. If we click on it, in the bottom half of the screen, we will see the details. We can then click on the Inbound Rules tab. As you can see, there are no rules specified. Since we are going to use MySQL as database and by default MySQL runs on port 3306, we want to allow inbound traffic on port 3306 only from the Spring Boot security group, as per our diagram. This means that no other box in the world will be able to access our database, except from the boxes where Spring Boot is running. So we can click on the Edit button and select MySQL/Aurora from the drop-down, and note how the port 3306 is selected. If we now click on the source text field, we will be presented with a list of options. We can select Spring Boot SG as value. This means that only traffic coming from boxes running within the Spring Boot security group will be allowed to hit the database. Now, we will set the Spring Boot security group to accept only 2 kinds of traffic: on port 8080 from the public security group, and on port 22, which is SSH, from the Bastion host security group. For the public security group, we will allow access on port 80 and 443 from anywhere, and on port 22 only from our public IP address. To indicate that traffic is allowed from anywhere, we use the CIDR address 0.0.0.0/0. To find your public IP address, you can visit whatsmyip.com. Please note that if you don't have a static IP address, your public IP address will likely change, and therefore you need to come here and update the security groups when this happens. Otherwise, you won't be able to SSH into the box. Also, after your public IP address, you should add a / and the value 32, meaning that this is the only address allowed to SSH into the public boxes. Finally, on the Bastion host security group, we will allow only SSH traffic on port 22 from our public IP address. We have gone through a lot in this lecture. We have set up a VPC with public and private subnets, route tables, an elastic IP, a NAT gateway, and security groups for all logical layers of our application. In the next lecture, we will create one Apache HTTP server, one Bastion host, one Spring Boot box, and one MySQL database, as well as setting our application configuration on an S3 bucket. We will then test that we can use the application on the cloud. The last thing you might want to do for now, especially if you are not going to follow the next lectures right away, is to delete the NAT gateway and then to release the elastic IP address associated to it, so that you are not going to pay any money. To do that, simply click on the NAT gateway link and select Delete NAT gateway. Once the NAT gateway has been deleted, click on the elastic IPs, select the IP address, and then select Release Address. You might have to wait a few minutes until AWS catches up, but the option will eventually become available. This means that currently our VPC doesn't have a NAT gateway, but this can be easily solved by creating a new elastic IP address, a new gateway, and assign the elastic IP to the gateway. You will also need to change the NAT gateway details in the private route table since when we deleted the gateway, the entry became invalid. Thank you for your time, and I see you in the next lecture.